Remember, a sequence is the progression of an ordered list of numbers. And again, like we mentioned before lunch, a series is a numerical value when you add up all the terms in the sequence. Remember, back from Algebra 2 or pre-calc, you were introduced to the sigma notation, which means it's a sum. Remember, the lower index, it tells you what term you're starting adding. The upper index tells you where you're ending. In this particular case, when you're dealing with an infinite series, you'll see that upper index as an infinity. Also, when you talk about listing out what the series is going to be, if it's infinite, you must always include that plus ... at the end to show that it is an infinite series. Again, the u sub 1, u sub 2, u sub 3 are called the terms. In a lot of cases, we can't actually calculate the infinite sum, even though we know it exists. We can start by examining the sequence of partial sums. So, for example, when you take a look at this series right here, when we talk about the first partial sum, it's just the first term. The second partial term is the sum of the first two terms. The nth partial sum is the sum of the first n terms. So when we talk about a partial sum, for example, here is my first partial sum. My second partial sum would come from adding my first two terms together, the 1/2 plus 1/4. So that would be what's referred to as my second partial sum. So 1/2 plus 1/4 is 3/4. My third partial sum would come from adding my first two terms together, 1/2 plus 1/4 plus 1/8. And then again, my fourth partial sum would come from adding my first four terms together. So 1/2 plus 1/4 plus 1/8 plus 1/16. What type of series is this? Is this a geometric series? Yes, it is. Because what is the common ratio? The common ratio in this particular series is what? 1/2. So remember the formula that you learned back in your pre-calc days? To write the explicit formula for a geometric series, the a sub n was equal to a times r raised to the n minus 1 power. Remember, when you have a listing of the terms and it is a geometric sequence or series, you can find the nth term or write the explicit formula. So in this particular case, when they want to find the sum of the nth terms, again, n equals 1 to infinity, we can write the explicit notation. The first term is 1/2 times my common ratio raised to the n minus 1 power. When you're given an infinite series and they're asking you about the limit as n is approaching infinity, the question is, does this sum exist? So when you have a geometric series, for the sum to exist, what has to happen with the common ratio? The common ratio has to be what? Less than 1. So remember to find the sum of an infinite series, geometric series, as long as the absolute value of your common ratio is less than 1. The formula that you can use to help you calculate what the sum of the series is, you take the first term, you divide it by 1 minus the common ratio. Look familiar, I hope? Or ringing a bell a little bit? So in this particular case, I know my first term is 1/2 divided by 1 minus 1/2. So then we could say the limit as n approaches infinity of the sum of this particular series is going to be 1. So if you can find the sum of the series, we say that series is converging to whatever the sum is. So again, the S is standing for the sum. And again, if the sum cannot be found, we say the series is going to diverge. All right, so if you can't find the sum, we say that the series is going to be divergent. All right, so let's again talk about your geometric series. So like I just mentioned, if you have a geometric series, remember it will converge if the absolute value of your common ratio is less than 1. Yes, Patrick?
So how do we know that the sum is a over 1 minus r?
That's the formula for the sum of your infinites. Again,
How do we know that?
oh, where does the formula come from?
Yeah.
I'll have to look at, there is a proof, I'll have to look it up. So if we have time at the end, I'll get it out for you. Okay? It will diverge if the absolute value of your common ratio is greater than or equal to 1. All right? So again, like I just showed you, if we want to know what the geometric series is converging to, if it's geometric, we can take a term and divide it by 1 minus r. So they're telling you that these are geometric series. And the question is, we want to know if these series are converging or diverging. And if it is converging, they want us to find the sum. So there's 2 ways you can go about doing this. Number 1, you can always try and take these formulas and put them in the form of a times r to the n minus 1. And then you could identify what the common ratio is. There is more than one correct formula that can be generated to represent a geometric series. But every geometric series can have a formula written in this format. So for example, if you take a look at all these examples, none of them are really written in the form of a times r to the n minus 1. If I wanted to, somehow, some way, I could take all of these formulas and put it in that format. So not all geometric series may be given to you with an explicit formula that's written as a times r to the n minus 1. Or what you can do, since you know it's geometric, you can write out the first few terms. To find r. Because they're telling you it's geometric. So if I know the common ratio, I'll be able to know whether or not that ratio is less than 1 or greater than 1. So remember, to find your common ratio, you can take a term and divide it by its previous term. So if you're not sure what the common ratio is, you can take a term and divide it by its previous term to calculate what the common ratio is going to be. So for example, if you take a look at A, if you want to write out the first couple terms, again, be careful, this lower index is not a 1. Some of these series may start at 0, which in this particular case it does. So when I plug 0 in for k, I know 4 to the 0 is 1, so my first term is going to be negative 5. What's my next term going to be? Negative 5/4. And then my next one's going to be negative 5 over 16, or 4 squared. So then what's the common ratio going to be? Now be careful, remember, just because you see a negative sign does not automatically mean it's going to be an alternating series. Again, the negative sign is not being raised to the k power, so it's not creating an alternating series. Every term in this series is negative. So what is the common ratio for this particular series? The common ratio is what? 1/4. So again, the absolute value of 1/4 has to be less than 1 in order to converge. So is this geometric series going to converge? Yes. So it converges. So then to find the sum of this particular series, or to find out what it's converging to, I'm going to take my first term, which I found to be negative 5, and I'm going to divide it by 1 minus 1/4. I like to simplify my complex fraction, multiply everything by 4, so that's going to give me negative 20 over 4 minus 1, which is going to give me negative 20 over 3. So I know that this particular series is going to converge to negative 20/3. So any questions on example A? Taking a look at B, again, starting with 1. Again, if you want to list out the first couple terms, when I plug in 1 for k, that's going to give me 3 squared, which is 9, times 5 to the 0, so that first term is going to be 9. Plus, when I plug in 2 for k, that's going to give me 3 to the 3rd, which is going to give me 27, over, now 5 raised to the 1 minus 2 is going to be 5 to the negative 1st, which is going to give me a 5 in the denominator. Yeah, did I multiply?
The k would be 2, so it would be 3, 4.
Oh yeah, 81, thank you. You're right, 81, thank you. So 81 over 5. What's the common ratio going to be? 9/5. So is the absolute value of 9/5 greater than 1, or is it going to be less than 1? Greater than 1. So what can you tell me about this series? Is this series going to diverge or is it going to converge? It's going to diverge. Okay. So any questions on A or B? So now let's take a look at C. Again, we've got the series that is 1 over 2 to the k minus 1 over 2 to the k plus 1. So when I plug in 1 for k, that's going to give me 1/2 minus 1 over 2 squared, which is 4. I'm just going to go ahead and write these out, and I'll simplify them. When I plug in 2 for k, that's going to give me 1/4 minus, again, that's going to give me 2 to the first, which is 3, so that's going to be 1/8. Well, I know 1/2 minus 1/4 is just going to give me 1/4. 2/8 minus 1/8 is going to give me 1/8. So what's the common ratio going to be here? The common ratio is going to be what? 1/2. So to find the sum, because again the absolute value of 1/2 is indeed less than 1, so I know that this series is going to converge. So then to find my sum, it's going to be 1/4 divided by 1 minus 1/2. So what is this going to converge to? What's the sum of this particular series going to converge to? It's going to be what? It's going to be 1 over 2. Okay? You guys go ahead and try the next one for me. Tell me whether or not that's going to converge. This particular formula and split it up into negative 2/3 times k times negative 2/3 to the first. So again, this also will give me what my common ratio is going to be, or you can continue to list out the first couple terms. Again, because I know the absolute value of negative 2/3 is less than 1, it's going to converge. So the sum then, now my first term starting with 1 is going to be 4/9. So 4/9 divided by 1 minus a negative 2/3. Make sure you plug in that negative 2/3 into that formula. It's not the absolute value of R. So once I simplify this, this is going to simplify down to, and again, multiply everything by 9. That's going to give me 4 over 9 plus, that's going to give me 2/3 times 9 is going to give me 6. So 4 over 15. Okay? So, and you've done problems like this back in pre-calc, or you've done them back in algebra 2. So any questions about whether or not what makes the geometric series, or how you can calculate whether the geometric series is converging or diverging? Another application of the geometric series is find a rational number. So when we talk about finding a rational number, we don't want it to be a decimal. It's going to be a fraction or an integer. That is represented by the repeating decimal 0.51, 0.51, 0.51. So we're trying to figure out what fraction, when I divide, produces this particular repeating decimal 0.51, 0.51, 0.51. Repeating decimals are actually an infinite geometric series. So in other words, I can take this repeating decimal 0.51, 0.51, 0.51, and I can break this up into a sum. I can write this as 0.51 plus 0.0051 plus 0.00051, etc. So now, being this particular geometric series, I know my first term of this particular geometric series is 0.51. The question is, what is my common ratio? My common ratio, I know I can take a term and divide it by its previous term to help me find the common ratio. So I can take 0.0051 and divide it by 0.51. So the question is, when I divide 0.0051 by 0.51, what's that going to divide out to be? That's going to give me a common ratio of what? 0.01. So now, what do you know about geometric series? Well, I know if the absolute value of my common ratio is less than 1. I know that it's going to converge, and I know that 0.01 is indeed less than 1. So I know when I add all these numbers together, it's going to be approaching the sum of my infinite series, which is a divided by 1 minus r. So my first term is 0.51 divided by 1 minus that common ratio of 0.01. So 0.51 divided by 0.99. So what's that fraction going to be? 51 over 99. And if you were to take out your calculators and take 51 and divide it by 99, hopefully we get this repeating decimal, which notice we do. All right, so we know that the fraction 51 over 99 is equivalent to this particular repeating decimal. Yes, Nate?
Don't most of these like repeating decimals, like you just take the number that's repeating and put it over 9 how many times?
But it is a series. Yeah, it is a geometric series. Yeah, but this is why. This is why it works like that. All right, any questions on how you can take the repeating decimal and rewrite it as a geometric series? Okay, the new series we're going to talk, jumping ahead of myself. So a lot of questions involving geometric series. They'll give you a series involving variables and they'll want to know what it's converging to. So for example, use this geometric series, and again, we want to show that it's converging between -1 and 1. So I'm going to take you through example 4 before we do example 5, because in example 5 it's not telling you what the interval of convergence is going to be. So again, we know it's a geometric series. So I know that the sum of my infinite series is going to be a divided by 1 minus r, as long as the absolute value of my common ratio is less than 1. So first of all, what I want to do is I want to figure out what this common ratio is going to be. So let me first of all find my 0th term. So when I plug in 0 into this particular formula, now remember, x to the 0 power is just going to be 1. And -1 to the 0 is 1. So a sub 1. When I plug in a 1, that's going to give me a -x squared. So then to find my common ratio, it's going to be a sub 1 divided by a sub 0, which is going to be -x squared over 1, or just -x squared. So I want to know where it's going to converge. So in order for this series to converge, I know that the absolute value of my common ratio, which is -x squared, has to be less than 1. So now what you're going to be doing is solving absolute value inequalities. So again, I know that when I have the absolute value of -x squared, again, remember when you solved inequalities back in Algebra 2, and they were absolute value and it was a less than. Remember you had to split it up as an and or an or inequality? So because this is a less than, I know I can rewrite this as -1 less than x squared less than 1. Again, so when I can rewrite this as -1 is greater than x squared and x squared is less than 1. Remember, they are equivalent. So when I take x squared less than 1, remember how you solve polynomial inequalities. I'm going to get a 0 on one side, so I have x squared minus 1 is less than 0. And remember, I factored this into x plus 1 times x minus 1 less than 0. So you found your critical numbers to be -1 and 1. Kind of remember doing this last year in your pre-calc days. You did that number line test. You wanted to find the intervals where it was positive and negative. Remember, I want to know where it's going to be less than 0. So again, when I plug in a number less than -1, which is -2, -2 squared is 4. 4 minus 1, that's going to give me a positive. When I plug in a 0, that's going to give me a negative. When I plug in 2, that gives me a positive. So again, notice that the only place where x squared minus 1 is less than 0, where it's negative, is between -1 and 1. So I know that -1 less than x less than 1 is where this is going to converge. Okay? So any questions on that one? So now let's move on where they're not giving you the interval of convergence. Let's take a look at the next one. So again, find all values of x where the series converges and then find the sum of the series for those values of x. So for example, well, I'm listing out the terms. So let's talk about the common ratio. Find your common ratio first. What's the common ratio between this particular geometric series? The common ratio is what? It's going to be what? 2 over x. So in order to converge, I know the absolute value of 2 over x has to be less than 1. So now when you have an absolute value and it's a rational inequality, somehow, some way, in order to solve this, you've got to get the variable out of the denominator. So the way you're going to do that is you're going to take the reciprocal of the fraction on the inside. So I'm going to rewrite this as x over 2, and when you do that, you simply flip your inequality sign to be greater than 1. Because you've got to get that variable out of the denominator in order to solve this absolute value. So now you can rewrite this. This is a greater than inequality. So you can rewrite this as x over 2 is greater than 1, or x over 2 is less than 1. Remember, when it's a greater than inequality, you write it as an or. So now to solve for x, I'm going to multiply by 2. So x is going to be greater than 2, or x is going to be less than 2. So that's where it's going to converge. So now you guys go now to find the sum, because it's also asking you to find the sum of the series. So to find the sum, I'm simply going to take the first term, which is 1 over x squared, divided by 1 minus the common ratio, which is 2 over x. How do you solve that? Complex fractions. So what do you multiply everything by? You multiply everything by a what? X squared. So that's going to give me a 1 over x squared minus 2x. So that's what it's converging to. Any questions on that one? Take a look at B. What's the common ratio? Sine x times what? They won't have, so -1/2 times the sine of x. So then I know to converge, I know the absolute value of -1/2 times sine x has to be less than 1. Again, it's an absolute value inequality less than, so I can rewrite this as -1 less than, I know the absolute value of negative, that's going to be positive, so 1/2 sine x less than 1. How do I get sine x by itself? What am I going to have to do? I'm going to multiply everything by a what? 2. So -2 less than sine x less than 2. Does that make sense? What's the range of sine? What's the range of sine? Thinking of inverses when you say negative pi over 2 to pi over 2, but just the parent function sine of x. Not 0 to 1. Negative 1 to 1. So the place this is going to converge is just going to be between negative 1 and 1, because the range of sine of x is only going to go from negative 1 to 1. Okay? So now to find the sum, I'm simply going to take my first term, which is sine of x, divided by 1 minus the common ratio, which is negative 1/2 sine x. So I have sine x over 1 plus 1/2 sine x. And you could simplify that by multiplying everything by 2. So these are some twists and turns on those geometric series problems. So any questions on the geometric series before we talk about the telescopic? Okay, so this is a new series. Telescopic sums or telescopic. So the reason why we call this a telescopic is because if you think of a telescope, you kind of pull it out and you pull it back in, it collapses. So that's exactly what happens with a telescopic sum. A telescopic sum or series has this particular pattern. You'll see 2 terms that are subtracted added to another 2 terms that are subtracted. So what happens with a telescopic sum is that when you write out these first couple terms, what happens is the sum is going to start to collapse. And you're going to be left with just a couple terms. So when we talk about the sum of a telescopic series, it's simply going to be whatever the remaining terms is minus the limit as n goes to infinity. What happens is all those terms out to infinity are going to start collapsing and they're going to start canceling each other out. Don't always assume it's the first term minus the last term. You must always write out the first few terms to see the pattern, to see which terms are canceling, to decide which terms cancel and which ones remain. This whole chapter, most of the time, I don't care what these series are converging to. They're not going to ask you what it's converging to. We just want to know whether it's converging or diverging. But if you ever have a question, and you will, and they want to know what is the series converging to, if they ask you that question, it's only going to be 1 or 2 types of series. It's either your geometric or your telescopic. Most of the other series, you're not even going to be able to find what it's converging to. So the only series that we're going to be able to actually calculate what it's converging to is if it's a geometric or telescopic. So right away in the question, if they ask you what is the series converging to, be on the lookout for the geometric or the telescopic. All right, so this is what a telescopic looks like. So most of the time, they're pretty obvious that it could be telescopic because you're going to have one expression minus another. So it appears that this is going to be telescopic, so what I'm going to do is just write out the first couple terms. Don't simplify. Leave it as 2 separate terms. So 1 over 1 minus 1 over 3. Plus, my second term is going to be 1 over 2 minus 1 over 4. My third term, 1 over 3 minus 1 over 5. I'll take it out one more time. 1 over 4 minus 1 over 6. And again, I know it goes on forever. Now, if I start combining like terms, you can see where the cancellation is going to happen. Notice you have a negative 1/3 right here and a positive 1/3 right here. So you know they're going to cancel out. You have a negative 1/4 right here. You have a positive 1/4 right here. And if I was to take this out more terms, you agree with me that negative 1/5 would cancel out when I plugged in 5 for n. All right, and same thing with the and it would continue on. So that's the collapsing of the series that I was talking about. So what are the only two terms remaining in this particular series that are not going to cancel out? 1 and the 1/2. So if I add 1 plus 1/2, that's going to give me 3/2. So again, this series is going to converge. Okay, so that's how the telescopic works. Okay. Like I said, when you have a question like this on Tuesday, we're going to talk a lot about the P-series, and we're going to talk a lot about, you're going to be able to know just by looking at this on Tuesday whether it's going to converge or diverge. But the problem is they're asking you to find the sum. And the rule that we're going to have and the type of series that we're going to have, there's no rule to tell us what it's converging to. We'll know it converges. But the only way you're going to know what the sum is if it's telescopic or whether it's geometric. So what you're going to have to do is, we did this back in Chapter 7, which I know is your favorite. You've got to split this up into two smaller fractions. So you're going to have to do your partial fraction decomposition to get it into the telescopic form. So again, remember, this is where we did that a over k plus b over k plus 1. Because right now, if I just started plugging numbers in for k, I would not see what terms are going to remain to see what this particular series is going to converge to. So this is where, remember, you multiply by the LCD. So 1 is equal to a times k plus 1 plus b times k. So this is where we're going to let k be equal to 0. K is equal to negative 1. So what's a going to be equal to? A will be equal to what? A is going to be equal to what? When I plug in 0 for k, k will be equal to what? Plug in 0, 1. So a is equal to 1. When I plug in negative 1 for k, what's b going to be equal to? Negative 1. So now I can take this larger fraction and I can split it into my two partial fractions into 1 over k minus 1 over k plus 1. So you guys go ahead and finish it for me. See what this particular telescopic series is going to converge to. That all the terms begin to collapse, the negative 1/2, positive 1/2, negative 1/3, plus 1/3, etc. So the only term standing is your 1. So any questions on B? So like I said, Part C, when we start learning more and more tests, you're going to know the convergence or divergence just by looking at this particular series. But what you're not going to be able to find without doing the telescopic is what it's converging to when they want you to find the sum. So the first thing you have to do is you have to take this larger fraction and you've got to split it up into your two smaller fractions. So you guys go ahead and do your partial fraction decomposition on that. What about for C? What is this going to converge to? 1/3. It's going to converge to 1/3. So the only term standing is 1/3. So it converges to 1/3. So like I said, guys, sometimes when you're asked to find the sum and it's not a geometric, but you see the fraction, you've got to split it up into the two smaller fractions, and you've got to do the partial fraction decomposition to find what the series is converging to. D, you don't have to do the partial fraction decomposition because you've already got the plus and the minus. You guys go ahead, write out the first couple terms. Tell me what this is going to converge to. See what the pattern is, so you know whether the canceling terms are going to happen, because this is an example where it's not necessarily the first term. All right, so any questions on the telescopic? All right, so that's where we're going to stop for the day. We'll do harmonic next class.